Thank you. It's an honor and a pleasure to be here. PowerPoint just crashed. That's really great. Okay, so let me just deal with this. Okay, that's a bit better. Excellent. It's a pleasure to be here. It's my first time in Poland. I've traveled a great deal over the years, but I've never had the opportunity to come to Poland again. And I'm really impressed by the beauty of this city. So firstly, thank you for the invitation, and it's a pleasure to be here. So what I'm going to do today is talk a little bit about how we got here in terms of the story of enterprise Java, and in terms of where I think things will go less. So at the beginning, I'm going to talk a little bit about history, and some history that's even kind of almost ancient history. But as we go on, I'm going to get into things that are much newer and more forward-looking. If you are interested in following me on Twitter, or of course saying anything you want to say about the talk, my Twitter handle is Springrod. Another way of thinking about this story of how we got there and where we go next is, where do we go after convention over configuration? I think that was a great leap forward in terms of productivity, and we've seen it embraced on many platforms, even finally the Java platform. But where do we go next? So if we think about the enterprise Java journey, we've learned a lot. I think we can safely say we've actually stopped shooting ourselves in the foot. We've stopped making our lives harder. We used to do a number of things that made life hard. We kind of learnt and we stopped doing that, and that was great. I think we've also gradually learnt that automation is important, and I would argue that we can automate a lot more. So, where we came from really was a pretty dark and scary place. If we go back, say, before the first GeeCON, say if we go back to the early 2000s, it was called J2EE, and it was really nasty. It was nasty and unpleasant. Working on J2EE applications was kind of a bit like this. It was a scary, complicated machine, and you'd tinker with the dark magic within it. And you'd do a lot of tinkering, and eventually you'd get a very limited amount of functionality compared to the amount of code you have. Of course, it didn't literally look like this. It literally looked like this. So we had, of course, this magical stovepipe stack, and we had, going along with it, we had a whole bunch of patterns. There were things called core J2EE patterns, which were, broadly speaking, ways you avoided doing any actual object-oriented programming if you were writing enterprise Java applications. This was really quite bad. Why do I bring it up? I bring it up firstly because it's actually funny, given that it's now over 10 years ago. And secondly, because the lessons that we learnt back then are still relevant. So amusingly enough, if you go to the Oracle site, you can still find the J2EE pet store. It was a marvelous, magical thing. So if you look inside it, you find deployment descriptors of bewildering complexity, and it's actually very hard to find any Java source code. As we know, Java is not the most concise language in the world, but actually the volume of Java is pretty small compared to the volume of everything else. Really, if you want to see this degree of pain and suffering, you can't find it in Java anymore. You really need to go to the JavaScript world, and you'll find a whole lot of the same kind of duplication stuff that really needs, in my opinion, something of a next layer of experience to simplify it. But that's aside. So what was wrong? Well, obviously there was too much code, and the fundamental thing really was there were too many artifacts, and even simple things were hard. There was ceremony around everything, the concepts were overblown, the 6 EJB roles, remember ear files, war files, there were all these concepts, and they were very, overblown. So people rapidly found that this didn't work too well for them. So what were the attempts to fix it? Well, the first attempt to fix it was basically not an attempt to fix it, but arguing that this was necessary complexity, that enterprise is hard, enterprise makes you strong, and that wanting it to be simpler represented hopeless naivety. Now, why would people think that? Well, many people genuinely thought that, but there were also vested interests in it. Like, I mean, there were very large vendors like IBM, Oracle, Sun, who had a vested interest in this stuff being so damn complex that you needed to be a mega vendor to implement the specs. And also, that kind of motivation was to some degree found in some of the architects who'd work on this. In my first book, I referred to the complexity industry. It is a great way to keep your job. If you've created something that is so complex and is built on a stack so bewilderingly complex that other people can't pick it up, that's kind of good for your job security. So that was a phase one. That went on for about 5 years, maybe, of denial of complexity projects failing or coming in over budget, and eventually people realized something needed to be done. One of the things that was tried fairly early on was code generation. So people tried it using enterprise-oriented IDEs like WebGain. They also tried it using Xdocklet. Anyone here remember Xdocklet? Anyone use Xdocklet? Was a good idea. Aslak is a clever guy, but it's not the fundamental way to solve the problem. And this brings us to a point that I'll come back to in this talk. Code generation. Is code generation good or bad? The answer is that code generation can be good, but it can also be bad, right? It's a tool that's very powerful and can be used to cover up other problems. Essentially, it can just be used to mask other problems. So code generation, I don't think we can say it's uniformly good or uniformly bad, but we've got to be careful. It's a bit like our friend Spider-Man. What is it? With power comes responsibility. When we start generating code, we really need to think, why are we doing this? Hey, why can't you write this code by hand? Is there a whole ton of duplication? Are there reasons that we can't write this code by hand? Some lessons we did learn from code generation are, I think, that you don't want to write code that no one would ever write by hand. If you're doing that, if you're generating code that no sane person would write, you're masking other problems. That's bad. You haven't solved the fundamental problem, you're trying to cover it up. Secondly, you have one of the core problems of code generation is that, you know what, you generate code, people are going to go on writing code. How do you understand what they wrote so if you want to do any round tripping, you can do that? So don't trample on the code that those poor people write. Thirdly, your generator itself shouldn't be opaque. So, it shouldn't be so magical that changing what comes out of it is almost impossible. So these are pretty straightforward lessons, but it turns out, particularly the second one's pretty hard to deal with, because if you want to round trip, you need to be able to understand code that you didn't generate, and you better not be putting, magic markers in people's code because they rightly hate that. You don't want to pollute their code with stuff that your generator needs. Okay, so code generation didn't solve the J2EE problem. You want less code. So PlanA is basically simplify the code you need to write. So, by 2004, 2005, we reached the era of the POJO, plain old Java object. Obviously, you might say I'm biased, but I think it is demonstrably true that the principal standard bearer of this was Spring, and it was fairly popular. The reason it was popular was it actually fixed some, but not all of the problems. It actually fixed them, rather than just pretended they weren't there or tried to generate a load of automated code to get around it. So what it did was it ensured you had less code, and it also ensured that the code you had actually looked like Java. It didn't look like weird design patterns that were in fact workarounds. It actually looked kind of Java-like. Obviously, in the early years, due to the deficiencies of Java at the time, people used a lot of setters, a lot of objects were mutable that didn't need to be. Over time, even that changed, and it was possible to do constructor injection and not make things mutable where they didn't need to be. So basically, we got to actually write in something that was recognizable as Java, and we ended up with a lot less code, and guess what? That meant we could write it by hand. There were, however, some things that weren't great. One was in the early years, there was quite a lot of XML that was addressed over time, but some of the complexity did migrate someplace else. And also, I think we found that large-scale OR mapping was pretty hard. I mean, products like Hibernate are powerful and useful, but nevertheless, when you try to do what a lot of people did and map their entire enterprise database, it started to get really difficult. And also, it turned out that project and process remained inconsistent. So every project was different. Every project was pretty hard to start up. It needed a whole bunch of configuration. It wasn't easy to start projects. And this relates to what I would term the pathology of enterprise Java. It's the pathology of enterprise. The idea that everyone is special is great at an individual level. Yes, everyone in here, we're all special, and everyone should recognize that. However, when we form ourselves into teams and build software, we should try not to build software that's that special. It's special in terms of what it does. It's special in terms of the business requirements that it satisfies. It doesn't need to be special in terms of how it builds. It doesn't need to be special in terms of a whole lot of things. So this really was a deep-seated belief that every application is special, which was ingrained in the enterprise in general and enterprise Java in particular. So that insight didn't come from the Java community, it came from outside Java. So when we got principally, the standard bearer of this was Ruby on Rails, Rails basically took an aggressive view of convention over configuration, right? Everything doesn't need to be special. Just do it this way. Don't argue about it. Do it this way. It's probably what you want. And by the way, it's 10 times faster than figuring out how to do it in an inconsistent way that will confuse everyone thereafter. This was really a very powerful lesson. And, it's like one of those things that at first seems too good to be true, but turns out actually to be really, really useful in most cases. In parallel with the rise of Rails, I think we'd gradually seen, even in the Java world, some tools that actually started to do this. And one of the notable ones was Maven. Anyone remember using Ant? Anyone created Ant builds? They were all different. They had library directories that had loads of artifacts. They were all different. It was really hard to work out what it did. And every build was truly custom. Whereas with Maven, we've got the notion of a POM, we've got the notion of plugins, we've got a directory structure that Maven really, really wants you to use, which represents a convention. So gradually, a few things in the Java world were beginning to move that way. Proved to be a very, very good thing. A lot of people attribute all the benefits of Rails for productivity in web applications to the language, the fact that it's Ruby and that it's a dynamic language. Look, that undoubtedly has some benefits for the kind of apps that work well in Rails, but it is not the whole truth by any means. So, there were two other things that Rails did that were really valuable. One was convention over configuration, and another actually was a pragmatic, effective take on code generation called scaffolding. So Rails actually did do code generation, but it generated code that you could have written by hand. But why would you write it by hand if it could be generated? That was an example of a good use of code generation. So it took a while, but eventually those lessons of convention over configuration made their way into the Java world. Took quite a few years, and I think it was partly that it took a while for frameworks to respond to that. So, for example, Spring and Drop Wizard and Play, but it also, more fundamentally, took for the Java community to be receptive. Like, I can remember when I was at SpringSource back in the late 2000s, we were really, really trying to push more kind of convention over configuration. I mean, we didn't, as I said, we didn't think of it. It was an idea that was advanced from outside Java. But we would try to push it, and we would get absolutely nowhere because there was an utter resistance. Back in those days, there was the belief that everything is special. Suddenly, as if by magic, that changed, and people suddenly found that they were happy using things like Spring Boot that really do use a lot of convention over configuration. So Spring Boot aggressively uses convention to detect things from the class path, start up your application with almost no configuration, and it also, of course, took advantage of the fact that over the years, the underlying Spring framework had gotten to the point where you could express a lot of things very, very simply. So that was a good thing, but it wasn't the whole story. It certainly advanced us a lot, but if you think about how we work today, there was another real stream of benefit that occurred. An example of this, or a primary example of this, is GitHub. How many of us use GitHub? GitHub is so familiar to all of us that it's easy to forget how magical it is. Seriously, if you think about the experience we have on GitHub versus the experience we had back in the days of Subversion or CVS or Rational Clearcase or SourceSafe or whatever, those tools were obviously not nearly as good or as loved by developers as the underlying Git, but also they did not have the collaborative capability that GitHub gave us. If you remember in the early years, GitHub used to talk about social coding. I don't think they use that tagline anymore, but it's where one of the key benefits of GitHub comes from. Why is this important? It's important because it enables people to collaborate. It also gives a lot better visibility into what's going on. So it's really easy to track, say, some of the things your teammates are doing. A couple of other trends that have been very beneficial on the process side are obviously the rise of CI and CD. In the days when we created our Ant builds that were all different, I guess the release process was, and I remember doing this, to go and say to someone on the operations team, hey, here's a jar file. It works on my machine. That was pretty much it. Whereas gradually we've moved to making that visible across a team as well. So there's a whole bucket of process benefits here that I think are really important. And again, with that, there's the idea of more standard deployment. So for example, people using things like Cloud Foundry, people using things like Heroku, where deployment also becomes less special. And there obviously these days, even in large enterprises, there is a great desire to move toward this more standardized approach to deployment. So you'd think everything's going just great. But you know what? We're in an industry where victory is impossible. Victory is impossible in our industry. Why? Because no matter what problems you solve, the business will come up with newer problems, right? They're insatiable. And we've all heard Mark Andreessen's true statement that software is eating the world. As software eats the world, there's more software to write. So no matter how good we get at writing software, people want us to write more software than we can possibly write. But it also turned out that there were some things lost in this transformation. One price of simplifying the services is you do actually end up with a lot of services. Imagine your one special enterprise application as being a really complex machine with thousands of little cogs in it. Now what we've ended up is a lot of microservices that are cogs that together form a machine. The whole thing is net simpler, but there is complexity that's migrated. There's also a problem that I think we've realized that the world is not going to become a monoculture. 10 years ago, it wasn't unusual, I think, for people to believe that Java was the future, right? Everything was going to migrate to Java. That's not the case. Java is doing very well, thank you. It's a healthy language. But we're not going to ever see a language in which everyone writes everything. I think that's been a very healthy learning process, the idea that there'll be more specialist languages, and there will never again be that kind of desire that we had with Java to shoehorn everything into the one language. So I've long believed that Java will be the last blockbuster language, that there will not ever be something that we don't have now that will be as big as Java. Increasingly, we'll see more fragmentation. And it's mostly a good thing, but it certainly can make coherence across all our services a pretty hard thing. So this is one of the reasons that people, when they look at all these little parts, think about the desire to have a mono repo or to try to make sense of it using some of the tooling they used to have before. Talking about that idea of the business being insatiable, Mr. Jevons over here, who had very, very fine Victorian facial hair, developed something called the Jevons Paradox, which basically says that if you make something cheaper, you're still going to spend as much time making it because people will want more of it. That's a rough summary. But so, for example, if you make travel cheaper, people travel more. So, when you make something easier to get at, people do more of it. And the same is with service creation. You make it easier, people make more services, and you end up with complexity. So if you think about where we came from, we used to have this monolithic application, but one positive thing was we had pretty good tooling to deal with it. So for example, we had in the Java world, we had IntelliJ and Eclipse. They're really very good tools for working with large code bases. So you had a number of teams who all interacted with this big sacred monolith, and at least they had decent tooling. By the way, these slides are taken from a New Relic article, so acknowledgement due there. So where we've ended up is something that's more like this, where we have services and we have teams, and there's kind of overlapping relationships between them. So, one individual, one team may be responsible for more than one service, and tooling becomes relatively problematic because you can't necessarily rely on having the same tooling applicable to everything. It's quite a good change, I think, but nevertheless, it adds complexity. This also leads to the problem that we can't love each service as much as we used to. Remember when we had our monolith, we loved it. Well, maybe we didn't love it, but we cared about it. Let's say we cared about it. We were hyper aware of it. We thought about it all the time, right? That's a part of love. So if you define love partly on thinking about something all the time, the monolith was never out of our mind. Whereas now we've got a lot more services, and basically they can't individually get quite as much love and constant care and feeding. So this is often referred to in the microservices world as pets versus cattle. So, the dog on the left is infinitely cuter than any monolith was, but on the other hand, the monolith also got a lot more attention, like that dog's going to get, versus all the cattle who, are our kind of semi-anonymous microservices. So, how do we cope with these changes? Well, I think we need some new forms of automation that combine both what we've learnt about how to work with code and how to simplify code with some of the things we've learnt about process standardization and process scripting. So one of the things that we've seen many users do is look to new forms of collaboration like Slack. So I don't think it's quite as popular for this purpose in Europe, but certainly what we're seeing, say in the US, is there is an enormous amount of Slack usage where people are trying to use Slack teams to assist in collaborating. So to add to that kind of collaboration that you got with GitHub. Why would you want to do this? Well, it turns out that, Slack teams and channels are a fairly good model for the way in which you have all these services and you've got groups of people who need to interact and collaborate on a particular service. Secondly, bear in mind that we've got our cattle. How are these cattle produced? Well, the production of these cattle is industrialized, and the production of our services really needs to be industrialized. In a world of cattle, we need to make it easier to create services and easier to evolve services and keep them consistent. We also need better tools for working with code because software may be eating the world, but code is eating software. Think, for example, about infrastructure as code. There's a whole bunch of stuff now that's checked into your Git repositories that a few years ago would have been purely done through operations management rather than being versioned. So I think you really need to go beyond scaffolding to easy, consistent service creation. And what I'm going to do in the remainder of the talk is talk about some of the ways in which we're trying to deal with this at Atomist. So some of the ideas we have on service creation and service evolution, and also what I would argue is a really important concept of process as code. It's certainly not a concept that's unique to Atomist, but I think this is an industry where we need to go. So let's think about service creation. So firstly, I'm going to describe how this next demo is going to work before I flip over to run the demo. But remember I said that with generation, you should have non-magical generators, right? You should be able to change how your projects will be generated in a very easy way. How would you ideally want to do that? Well, a really good way of doing it would be to use Git or GitHub. So for example, to have the template content for your generator be a repo. So basically the way our generation works is that you select a template repo and then we tailor it for requirements. So instead of, for example, having code that emits an application through a mixture of template content and actual code, like for example, the way start.spring.io is implemented, what we do is we take a working project, we run transformations on it to make it another working project. So let me just demonstrate what I mean about this. So I wasn't sure about network, and some of these things involve build, which takes time, so I decided to make recordings. So what I'm going to do is start this one off. So you will see here that we're in Slack. So, we've adopted this idea that we're seeing a lot of people have that, it's really good to have your, a lot of things around interaction with your project in Slack. So here I'm in the general channel, and what I'm going to do is run a generator. So let's see how easy it is to create a project. So here, oh, what happened? Oh dear. Okay, thank you very much for that. I'm sorry, I know what happened. I went on, I thought it would track me to the second screen, and it did not. So thank you for that. Okay, QuickTime Player, we're going. That would be more interesting if you can actually see it. So, I know what the problem is. I'm going to have to get out of the PowerPoint presentation flow. Didn't think of that. Okay, so now if I do this, is that better? Yep, that's better. Thank you for that. Okay, so what I'm going to do is rewind. And here, as I said, we're in Slack, and we're going to ask the Atomist bot to list generators. So this reflects our belief that it should be incredibly easy to create projects, and ideally, when you create a project, you shouldn't be just creating the source code. You should be creating something that lives in a repository and has, potentially the ability to have issues around it, have collaborators. You shouldn't have to set that stuff up. So now Atomist is going to ask me what that project should look like, but in the meantime, let's look at what's in the seed project. This happens to be a Spring Boot project. It's a pretty much bog standard Spring project. As you can see, it doesn't even have any template placeholders in it, right? It's a normal project, it builds. So if you want to make changes to that project, you can make changes to that project. And it actually has a hello world endpoint, which as you can see is in the Java com.atomist Spring Team, com.atomist Spring Team package. So this is an absolutely bog standard Spring Boot project, very similar to what you get from start.spring.io. So now Atomist is going to gather some parameters to create that. And here, I mentioned Maven. Maven is a pretty good way of building your applications. Not the only way, but it's a pretty good way. So we're going to create a information necessary for a Maven artifact, and we're going to choose the custom root project we want. Then when we've done that, we're going to run generate. So what Atomist is doing at the moment is it's reading the seed repo. So you can see here this repo, the Spring REST seed repo. It read the current contents of that, and it created a new GitHub repo from it. Obviously, before you do this, you authorize Atomist with your team and link your Slack team to your GitHub team. So here is our project, and the next thing we might want to do is go to the channel that was created for that project. So remember that idea I said about people finding it really useful to associate channels with services? Becomes important when you have a lot of services, right? This is a way of structuring your code or your overall system, and it's really useful to be able to associate a channel so that people can join or leave that channel as they want to collaborate or learn about that project. So when we go to the channel, we can issue commands that relate to that project, and we can also see things like the commit information about that project. So what we're going to do next is ask Atomist to help make this project build. CICD is an important thing to do. It can also be a little bit of a pain to set up. So we've asked Atomist to do it, and what it's going to do now is make some changes to the repo to put the build in file, and also go and talk to the Travis API and ask it to build this project. So the builds can take a while. This is one of the reasons I recorded it, to accelerate this. So now if you look at what it did to the actual repo, I'm sure I did click on that. What it did to the actual repo is, you can see it's made a commit where it's put this travis.yaml file in. This is one of the core ideas we have called project editing, right? We have the ability to act on your repo or potentially local code base in a consistent manner, essentially in a scriptable way. And of course, to do that, you need to be able to first parse stuff in the project so you understand what you're doing. So there's a bunch of boilerplate here. I'm not a shell script person, so I barely understand this. However, it does work, and it's resulted in the creation of yet another build over at Travis. And when that build is concluded, we will be notified about it. And so the build passed, so now that could be an indication. It'd be a good idea to merge that pull request, and we can do that again right inside this project context. And of course, that will kick off yet another build. CI and CD is a great thing, but boy, does it consume a lot of compute infrastructure. Okay, now seeing if I can get back into my okay, yep. So as you can see, we started off with this idea of a starter repo and it being transformed to be the kind of repo you want. So if you make changes to that starter repo, it will be instant in terms of the effect on the next generated project. So now let me figure out how I get back to Slack. This is a somewhat difficult transition. Okay, so now what I'm going to do also is create a library. So, some people regard it as a little bit of an anti-pattern, but the fact is that very often it is necessary to create libraries. And guess what? We'd use exactly the same approach. We'd use the seed generator. The seed generator points at a different repo that represents the starting point you want for libraries in your org. Exactly the same kind of thing. Edit this. Instantly, new things will appear in the next repo you generate. So very much the same as what we did. And here we've got the com.atomus Spring Team. Watch that, because that's going to get transformed fairly shortly. So we're walking through the flow step. I might accelerate this a little bit because you've seen these steps before. So let's go through and let's see what we got in the generated repo. See, we put in the parameters com.atomus GeeCON lib, and it's actually transformed it to be in the new package. So this reflects some of our belief that basically you should model new project creation as taking a working project and transforming it rather than using magic templates. Why is this good? Means that you can easily change the template. It means the template can build. You know if you've messed up the template. You know that instantly. Okay, so that is one of those challenges I mentioned around easy creation of services. What about the more challenging thing about evolution of services? Cascading change. So one of the ideas we have about this is, if you created a whole bunch of things from your seed repo, what would happen if you modified your seed repo? Probably modifying it for a reason, right? You're probably correcting something. You're obviously changing it to reflect something that should be in all future repos derived from it. But what about repos that have already been created from it? Well, we believe in some cases you should automatically propagate those changes to repos that were created from it. Propagate them in terms of a branch and potentially a pull request rather than obviously going and messing with master. Because I think we all believe that the idea of a pull request being a good workflow is a good idea, and even better, you shouldn't ever propose a pull request unless you're pretty sure that something builds. So let's have a look at the way we do this. So what we're going to do is demonstrate that when a change occurs to the seed project, if Atomus understands it, it's going to try to propagate that change to downstream projects. Okay, let's have a look at what this does. And I've got the same problem. This is really confusing. So, okay, so I'm going to go in here to... Okay, and off we go. So what we're going to do is go to the seed project, and I don't normally edit code in the GitHub UI. I do often use tools, but in this case, the easiest way to do it without needing to clone the repo was to do it in the GitHub UI. So here, obviously, the model that leads to the propagation of change is commit to master, right? If someone committed something to master, that's obviously meant to be an important change. Now you can see that Atomus has given us a message in the general channel of our org saying, do you want to roll out those changes that you made to the seed project? So it's actually seen the message. There are obviously rules for what changes can be cascaded, and of course they're completely customizable in code. But in this case, if we say yes, it's going to try and roll out those changes to derived projects. So let's see what happens here. And okay, we've got our GeeCON 2 project, and we'll see we've got a new commit on it. And the new commit has the file that was added to the master. So at this point, this is a branch, right? It's not, we haven't messed with master, we haven't even raised a PR. We've created a branch that contains the thing that it appears that someone wanted to do based on what they did to master. So this is one of the ways, oh dear, I knew I was going to do that. That is not good. Sorry about that. So this is one of the ways in which we're trying to express the idea of the relationships between services. You don't, in a microservice world, you don't want every service to be the same. I mean, it is good to have a little bit of experimentation, to have a little bit of difference, but you do not want chaos. You do not want, for example, the time that there's a critical security problem in some library, you to have absolutely no idea which of your 70 services use that library. It'd be kind of nice if you were keeping things up to date, and this is one of the ways in which we can do that. So, for example, we can upgrade a version, and that will roll out. So this comes down to this idea of process as code. There's a core workflow here that we think is very important, which is that you make an automated change in terms of a in terms of a branch commit, see if it builds, and then raise a PR. So we want to be helpful here. We want to make people's lives simpler rather than to make them more complex. And obviously, if you raise a PR that mightn't even build because it fails tests or whatever, that's not good. That's not making people's lives simpler. That's wasting their time. So this is a fairly fundamental idea here of the PR being raised only if the build passes. So this obviously means that we need to have a model that goes far beyond code, that even goes beyond GitHub. So we need to have a model that relates Slack channels to projects. We need a model that relates issues to projects, that basically also can track builds. So let's have a look at what I'm talking about in practice. So let me flip through this transition, which I'm finding extremely hard. And so, whoops, no, that is not the one that I want. This is the one that I want. So what I'm going to do here is a command called upgrade. Oops, no, that was the wrong one, sorry. So what I'm going to do is run a command called release library. So here, what I've typed into Slack is release library. It will ask me which library I want to release. I say GeeCON lib, and what it will do is rev the artifact ID because it understands the POM and can do a nice clean edit on the POM. And then it will commit that to master, and it will go and look for anything that depends on it, make a commit to a branch for that, and wait to see if all those commits build. So for example, imagine you've got a library, you've got 10 projects that depend on that library. Every one of those will have a new branch commit that revs to the new version of the library. Then it will wait to see what happens with the build on that commit. If the build passes, what do we want to do? Probably want to raise a PR, right? Why should you be behind on a library if you know that you can upgrade? If the build fails, what do you want to do? You want to raise an issue, and you probably want to notify people in Slack. So for example, ideally you would want to notify the library authors saying, hey, do you know that you've broken foobar service? They depend on you, and your latest version breaks them. And also you might want to go to foobar service and say, hey, I tried upgrading to this library and it didn't work. I've raised an issue for you. So let's see how this works in reality. And what we're doing here is we're waiting for the build, though I probably edited this bit because Travis can be a little bit slow. It's now looking for consumers of this to upgrade. Guess what? It found a consumer here. It found the library GeeCON 2. Depends on that. So what it did is a commit to a branch that made that change. So it hasn't even raised a pull request. I mean, it hasn't necessarily demanded anyone's time at all, but it's made a nice clean commit here where it updated that dependency in the POM. And as you can see from the branch name. So now we need to wait for the build, because if the build succeeds, we might want to take further action. If the build fails, we also want to take further action, but we want to take a different further action. Much as I love Travis, it really isn't this fast even to build small Java projects, so I did edit this out a little bit to get it down to a manageable length. Okay, guess what? The build succeeded. So Adamus decided that that branch that it created in each downstream library should be promoted to a PR. So if we wanted to, we could just merge it here, though very often we probably would want to have a look at it first. So why don't we have a look at it first? And I assume that I did click on this. I must have clicked on this. So, okay. I'm sure I went into this branch. This is a frustrating thing about running a recorded demo. Okay, right. So we're going to actually click on it. And what we will see is that the PR says fixed and upgraded POM version. Obviously, we've already seen what the diff is. So it's a nice, clean diff. Okay. So this reflects what we call project process as code. And it has to be based on a pretty comprehensive model of the project. How does it actually work? Well, what we are building is actually a platform rather than a tool that has a specific purpose. So this is some of the code behind the library release. So it actually works with the model. The model is accessible through JavaScript or TypeScript. And as you can see here, it's decided to run an editor on the particular projects. So essentially you can interact, sorry, I advanced. I was trying to, so it basically gives you a model for these things here and a pretty nice programming model around it. This also reflects, by the way, a personal thing. How many people have looked at TypeScript? TypeScript is absolutely great. TypeScript is a surprisingly good language. So if you need to do things on the JavaScript platform, one aside is I strongly recommend you check out TypeScript because I think the team have done a fabulous job on it. So that's one of the reasons we chose it for the excellent tooling. Okay, hopefully this has whetted your appetite for the notion of development automation and process as code. I truly believe that whether it's Adamus or other solutions, this is a really important space that deserves more and more attention. It involves things like, as I've said, you need to make creating services simpler. When you create services, you shouldn't be just creating a zip file or creating code on disk. A service is something that lives in a repo. It's something that has collaborators on it. It's something that has an associated collaboration forum like a Slack channel. It's something that has a build. Creating a project is not as easy as just emitting code. But if you want to emit code, I really think that this notion of taking a seed project that works and is editable and buildable and works in your normal tooling and transforming it via what we call editors to a unique end user project. I think that's a very nice way of doing it. The code manipulation that you saw, the evolution, so for example with the cascades, is based on the fact that Atomist is able to understand your source. In fact, it parses your projects. It can parse Java, it can parse Scala, a number of other languages. It obviously parses the POM. There's also a fascinating concept that we got from a Stanford paper called microgrammars, where you can write these little fragments that are more powerful than regular expressions and which you can use to pull content out of repos. You can also, if you want, obviously use regular expression find and replace, and you can do that across many repos in your organization. So process as code is something we think is very important. We think that essentially what we're doing here is just the start, and I think you will see a lot of community projects and vendors eventually in this space where we have notions. We're already seeing some of these out there like Snick, where you've got a helpful robot that adds pull requests to improve your code, where you have the ability to capture your process and culture as code, where eventually, if you have all this information about your projects, including your the AST for your programming languages, we can capture that and allow machine learning on it. So we've seen a number of vendors doing, or number of large companies doing some of these kind of things in-house. So for example, Netflix have an internal tool that handles some of the library dependency upgrade stuff. There's an interesting Netflix blog on that, where they're doing that kind of thing like, I've got a library, how many services depend on this? Can I automate the relationship and potentially upgrade it? Because when you get to their scale, you need this kind of thing. So finally, we are building our first focused product around Spring Boot automation based on some of the things that I showed, but also more than that, including like tracking the life cycle through to deployment right in Slack. If you like what you've seen, go to atomist.com and sign up, or I'd be really happy to talk to you after the talk. I hope this was interesting, and it's been a pleasure. Thank you.